Hello YouTube, Matt here from Forensics with Matt, and in today's video I'm going to be talking to you guys about one of the projects that I did during my master's degree in computer science, and that program deals with steganography. So if you're interested in using steganography to hide data in images, or you're just interested to see how I implemented the algorithms of least significant bit steganography, then stick around, and after the intro we'll get into the nitty-gritty details about how I did this. And so without further ado, roll that intro. Okay guys, so this is my GitHub page, and this is the project that you're gonna go to. If you want to try this on your own, make your own implementation of it, or do whatever. And so it's called XOR underscore LSB underscore Stego for XOR least significant bit steganography. And the actual thing that you'll get out of it is some sort of, or this directory called XOR underscore LSB Stego dash Unicode. And in that folder, there's a requirements file that I made. And this requirements file is going to give you all the requirements and download them. And you're going to need them to run this, and it's GUI based so that it's easier for you to look at things. And so invoking the XOR steg program with Python 3, I should change that after this video, but invoking that with Python 3 will give you a window like that, and you'll be able to select your image first, and then after you select that image and type in some text, you can embed that text in the image, and it'll embed it correctly. And if you want to extract data, again, you select the image and you press the extract button and it'll extract it for you. So yeah, and you can always read the paper. Actually, I don't think the paper is linked anywhere here. So I will try to find the paper. And we can go to the program now. So I was testing out Chinese before I started making this video. So I think the first thing that we should do is say, since this is Unicode, it can do basic Latin text first. So we're going to do, on my picture of Imper Soleiman, the word Turk. And this is embedded successfully. And so under the file Turk, we're going to go and we're going to extract that, and we see that Python gives us the exact same text. So it's good. And so this picture of Chinese dishes is the next one that we're going to use. So I believe this is my traditional Chinese one. And so I'll just type in a few letters, I don't know. And so these letters should be fine. And so I'll embed that text into you know what, I should probably okay, into something .png. It doesn't really matter what I use to embed it, but what name I use to embed it as long as it's there, but we should have that same text. And indeed we do. And so I have one with Thai food, so I'll just type in some random Thai. Okay, I forgot that I was still on Thai. And so if I go back to Thai food text, I should have the same thing that I inputted there. And it indeed is the same thing. And this is a picture of the Bangladesh flag. And so I tried Bangla. And we'll call that Bang, and it's embedded successfully in Bang. And we can go to Bang. And we see that it's there. And so I don't think there's any more that we need to do here. You know, just minimize that and we can open some pictures now. And so under my downloads, we'll open first the original picture of the Thai food will open. And where's Thai food text? .png. And so I have Thai food text on another. Okay, so I moved this from my other screen to the screen that I have. And you'll notice here that under in this picture, everything looks the same, and my goal, or our goal for steganography, is in fact to make everything look the same. And that goal is like 99% complete here, because you can see that basically all of the colors look the same. I'm trying to zoom in here. All the colors look the same except for maybe a little bit over on this hand right here. Actually, but not really on this hand right here. You put in the comments if you made it this far. Put in the comments if you think that the colors on this hand look a little different, because I'm not too sure. Actually, I'm zooming in. No, not really. But maybe you see things differently, so just put in the comments if you feel that on that hand there, the colors look a little bit different. But in general, in almost all of these areas of the picture, as you can see from me just panning myself around, the colors genuinely look 99% the same. So, and again, the goal for steganography is to do this because we don't want anyone who looks at your picture that doesn't know that it has steganography done on it to know that there was steganography there. And the reason why that is because steganography is a data hiding method. And if we're hiding data, we don't want people to know that data is hidden, except for the people that actually need to know that it's hidden there. And this least significant bit XOR steganography with Unicode text does that very well. And actually, let me open up my terminal really quickly to show you. Yeah, actually, it doesn't do anything with the peak signal to noise ratio or anything like that. I thought it did. Because with another version of it, it did. No, it didn't. 42. PSNR squared error. And so yeah, let me just read this off to you before I end the video. So it says that my program is a Python-based implementation of a novel image steganography technique described in the accompanying paper. This technique enhances the security of the least significant bit replacement method by introducing an XOR operation with the 7th bit of RGB components before embedding the data into the 8th bit. And all of this are your instructions in order to get this working right on your end. And so again, in summary, this is your program, and you can find a keyboard that's anything from Latin text with letters from Spanish, English, Turkish, and all those ones that use the Latin script, or to foreign things like Bangla, Greek, Greek, Thai and Chinese, Japanese, Korean, and others. And this program will hide it pretty well in an image without messing with the color very much, if at all. Like you see in these images that I just showed. And taking my work and improving on it will be a good way for any of you who want this type of method. Okay, it'll be a good way for any of you guys who want this type of method to have this type of method and have it done better and faster, and actually let me show you the file sizes of these as well. So when it came to the file sizes of these, this Bangladesh picture was 37 kilobytes. And where's Bang at? 601 kilobytes. 411 to 601. That's a little bit of a... Yeah, that's not that much of a difference. So something... Okay, the Thai food one, 4.9 megabytes to... the Thai food one. And so it ended up really becoming a super big one. And this is an example of data explosion, wherein things get way bigger than they should be. So hopefully someone can also solve this if you're watching this and you want to make this program again and not have a data explosion there. It'll be a great idea. And so this is the program. It's not that big. All it really does is takes in the image and does the process on it and goes through each of... Yeah, it also, the Steganography app part of it makes the button, and this is really the part that we're looking at here. Or no, extract text. So yeah, I have parts for extracting text and embedding the text, and yeah. In my main method, I make the buttons and I make functions for embedding the text and extracting the text, as well as general user interface business. So it's not too big of a program, but yeah, in closing, this can obviously be made better, and I'm thinking that someone can make that data explosion not explode too much. And so in closing, I hope that you enjoyed this introduction into my steganography program. And if you're interested in making this better, just DM me or go to my GitHub page and copy this repository and do it on your own. And yeah, this has been Matthew talking to you guys about my steganography program that I made during my master's degree. And until next time, Matt Out.